Okay, so there you have it, the chi-square value as compared to the critical value. Now you decide whether the data supports your null hypothesis or you reject your null hypothesis. Not too bad, right?
I guess not. It's not that bad. Could probably figure this out.
Great, so the three of you will have to help everybody else when they get back.
All my classes have been like this. I have no idea what's going on.
You know, guys, there aren't that many people in the library today.
We should totally make a chi-squared test to see if the number of kids out of class today matches the expected due to natural variation.
Dweeb.
Guys, this could actually be fun. I mean, you never know. Mrs. T could give us, extra bonus points on our next Mrs. T test.
Double dweeb.
Come on, Larry.
Alright, fine. But if anybody asks, we're just studying. We're not thinking that statistics could be fun or useful. Why am I friends with you guys, by the way?
Shut up. Let's do this.
Done. So we can conclude that the number of kids out of class today would be extreme as it is today, 0.001% of the time.
That can't be right. We messed up.
Nah, yo, check this out. Number's right there, 0.0001.
That's lower than our significance level.
That's lower than anybody's significance level.
Where could everyone be?
I don't know.
Well, we all have SRP, and if SRP isn't good for snooping around, then it's not good for anything.
Excuse me, where are you going?
Oh, we're just looking around.
You're not allowed to go back there right now.
Why not?
I don't know, I was told there's a meeting or something going on.
Really?
Yeah, you can't go down there,
Oh.
sorry.
All right. Guys, I think we can get past her. We just need some string, like invisibility cloaks, and a unicorn.
Or we could just walk past her.
Yeah, I think I like Larry's idea. Sorry, Jake.
Oh.
She what?
Are you saying?
She doesn't skip like class.
Yeah. Excuse me, where are you going? Excuse me! Oh no!
One, two, 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 one, two.
Hey,
one,
principal
two,
won't see you, please.
1, 2, 1, 2.
Now you three know why you're here.
You're running a child labor operation.
Okay, but you three did not do as an adult told you to do. Now, if you apologize to Mrs. Z, I won't give you a detention.
You're running a child labor operation.
Okay, I hear what you're saying. But it isn't child labor if they're happy to do it.
But they aren't happy.
I beg to differ. I think that they're quite happy. Can you prove that they're not happy?
Well, you can never prove anything. You can only support a correlation.
And the best way to support a correlation is with a simple random survey. It's statistics.
You better let us survey your wall makers and see whether or not they're happy.
Well, I guess I can let you do that. But if they're all happy, then you all are going to have detention.
Okay, so I have the results of a survey that you guys did a couple weeks ago about how happy you were. Remember, right after the quiz and you were complaining?
So we should do a two-sample hypothesis test. No?
We'll get better results with a matched pairs design. We just have to look at each student's first survey and then see how much they've changed now that they're in a sweatshop.
Right. So our null hypothesis is that there's an average change of 0 throughout the population.
And our alternative hypothesis is that there would be a change of less than 0, since there's a negative change in happiness.
Jake, Larry just realized that the opposite of happy is unhappy.
Whatever. Let's just make copies.
One, 1, 2. 1, 2.
All right, listen up. Fill out these surveys. Circle yes if you're happy, circle no if you're not happy. We'll pick a few randomly to reduce variation. Just fill out these surveys.
Let me get this straight. So we see the calculator, we pick them randomly, and due to natural variation, it shows 10 kids, but 3 of them were national sewing champions who all they like to do is just sew in sweatshops all day long.
When truly randomizing, you do get clusters of results.
So we fail to reject the null hypothesis and conclude that sweatshop kids are no less happy than they were before due to natural variation?
And we got a special place with troublemakers like you three.
And that is how we use Riemann sum to approximate a curve.
Oh! Now I get it. We totally should have increased the sample size.